Hey guys, I just wanted to do a short video over basically just running through example problems from the assignment that you're going to see tomorrow. So basically this is just a big paper review problems. Alright, it's not the review for our test, but it's just review problems. We just wanted to give you guys some more practice on some of this stuff. So it says find the radian measure of the angle with the given degree measure. So we're going to be given degrees, okay? And we're going to want to change it to radians. Keep answers as a simplified fraction with pi. Okay, so to go from degrees to radians, you take your degrees, which I'm just going to call D right here, and you multiply it by pi rad over 180. Okay? So, let's look at problem number 1. I'll just do the first problem for you. So we have a 76 degrees. So to change this to radians, I multiply it by pi radian over 180 degrees. Forgot to put my degree marker back up there. Okay, so since the 76 is going to be on top, it allows me to cancel out the degrees on bottom. And then basically you can use a calculator to reduce 76 and 180. So let's make that happen with the magic of this calculator. So 76 divided by 180. And if I hit math, enter right away, it'll change it and reduce it for me, 19 over 45. So that leaves me with, let's drop the calculator down. Okay, go away. Thank you. So that leaves me with 19 pi radians over 45. And I'm done. That's all there is to that problem. Okay, well, let's try problem number 4, which this time we're going the other way. Find the degree measure of the angle. So we're going to want to not multiply by pi over 180 now, pi radians over 180 degrees, but we're going to so understand that this is radian with the given radian measure. So there's an understood radian right here. I know we don't see it, but it's there, okay? So I'm going to multiply by 180 degrees over pi rad. Okay? And so I can cancel out the radians. I can cancel out the pi's, and then I just have to basically reduce 5 times 180, all divided by 7. So 5 times 180, that is, let's see, I think it's going to be like 900 or something like that. 5 times 180, yeah, it's going to be 900. And then, is this divisible by 7? Let's see if it reduces at all. Math, enter. It does not reduce at all. So we get 900 over 7 degrees. 900 over 7 degrees. Oh, my mistake. What does it say to do here? My mistake. I did not read entirely. That's my fault. Round to the nearest tenth if needed. So let's pull back up that calculator and see what this was. It was 128.6. So we should round it to 128.6 degrees. 128.6 degrees. And there you go. That's how you do those. Okay. Let's move on to the next set of problems. It says the measure of an angle in standard position is given. Find 2 positive angles and 2 negative angles that are coterminal with the given angle. Okay, I'm going to be nice and I'm going to help you out on both 7 and 8. Okay, I'm not going to do all of 7 or all of 8 for you, but I'm going to kind of give you guys some starting points, okay? So when doing these problems, it's important to remember, how do I find something that is coterminal? You add the circle. Okay, now you can add the circle as many times as you want, or you can subtract the circle as many times as you want. Okay, and so what I mean by that is, on the degrees, 360 degrees. So on like number 7, 65 degrees, to find a coterminal angle, I could just add 360 degrees. And that's going to give me 425 degrees. Okay, so that gave me one positive coterminal angle. You need to find another positive one. All right, now I'm going to help you find a negative one. How can I find a negative one? Subtract 360 degrees. And that gives me negative 295 degrees. And that's one of your negative ones, okay? So you need to find another way to find another negative one. Hint, you're going to do the same thing with a different number. Okay, number 8. 15 pi over 6 radians. It's understood, guys, that there's some radians here, okay? All right, so how do I do this problem? The same way I did number 7. Okay? See how you added 360 degrees on number 7? Well, with radians, to go around the circle, it's not 360, it's 2 pi. So you're just going to add 2 pi. And we're going to let the calculator do the hard adding for us because we hate fractions, even though we shouldn't. Alright? But we're gonna, since it's radians, we know we don't want to get rid of the pi, so we're going to leave it in terms of pi, so we do not plug in the pi. Math, enter, enter, and I get 9 pi over 2. Boom, there's one positive. So how can I find another positive? I'm going to let you do that. Okay? Well, how can I find a negative one? Well, instead of adding 2 pi, I could have subtracted 2 pi. Alright, so now I say 15 pi over 6 minus 2 pi. So I just say 15 over 6 minus 2, and I get 0.5. Now, here's the problem. You might be tempted to write that down as your answer. That's 1 pi over 2. It says to find 2 negative ones. Even though technically this is a coterminal angle, so in fact you could say this is your second positive coterminal angle. Okay? The instructions are very clear. 2 positives, so I actually helped you out and found you 2 positives. Okay? But you also need to find 2 negatives. So how could I go about finding another negative one? I could subtract another 2 pi. And when I said find another negative one, I mean find a negative one. I have yet to find one negative one yet. I'm about to. So minus 2, press enter, and that is, I believe, negative 3 over 2. Yes, it is. And so I get negative 3 pi over 2. So here's your first negative coterminal angle. What could you do to find your next negative coterminal angle? I will let you figure that out. Okay, so let's move on. That's how you do number 7 and 8. I actually gave you a lot of help on number 8. You just need to find one more negative coterminal angle. Let's go ahead and move on. Let's look at problem number 10. Find the length of an arc of a circle of radius 36 centimeters if the arc subtends a central angle of 4 radians. Okay, so first off, I'm going to go ahead and get you to look forward for a quick second. Every one of these 3 problems talks about radians. Find the measure central angle theta in radians. The sector of a circle of radius in 16 has an area 6 from 40 inches squared. Find the central angle of the sector in radians. Okay, because I took up that homework paper that gave you the 2 formulas, okay? So, here are the 2 formulas you would need for radians. To find an arc length is the arc length S is equal to the angle in radians times R. That's the radius. And then that's how you find arc length. And then the area of a sector is A is equal to 1/2 times the angle in radians times the radius squared. So those are the only 2 formulas you might need for 10, 11, and 12. Alright? So number 10, well actually number 10 is very, very simple. It's just plug and go. So I'm actually going to work out one of the more challenging ones with you. Alright? Let's do number 11. Find the, even though none of these are crazy. Well, let's do number 12 together. The sector of a circle radius of 16. So 1, they just told us something. That said radius of 16, so we should be in our brain cataloging this away as, oh, r equals 16, has an area of 640 inches squared. So the area of a sector is 640. Alright, find the central angle, so we're looking for theta, of the sector in radians. So we want to use this formula right here. So we say 640 is equal to 1/2 times theta times 16 squared. Alright, my suggestion to you guys has always been that if there's a bunch of stuff multiplying against a variable, multiply all the numbers together and then just divide by that number you get. So what I mean by that is, in this case I would get 640 is equal to, well, what is 16 squared, and then I need to multiply 1/2 by it. Pretty sure 16 squared is 256. Oh, that's right, so I multiply by 0.5, or I could divide by 2, it's the same thing. I get 128. So it's equal to 128 times theta. So then I just need to divide 640 by 128. I press enter, and I get 5. So the angle is 5 radians. That is what theta is. Alright, so hopefully number 12 helps you out, and also 10 and 11. In my opinion, 10 and 11 are a little bit simpler. Alright, so that's why I kind of, just gave you this ones. Alright guys, I wish you all the best. Okay, so earlier I said that the only formulas you would need were the ones dealing with radians. I lied to you because I forgot to check to see if there was a back. So, there is definitely a back. So you'll definitely also need to know how to find the arc length and area of a sector in degrees. So to do that, here's the arc length. So S is equal to theta over 360, okay, times 2 pi r. That's how you find arc length in degrees. And to find area of a sector in degrees, it's A is equal to theta over 360 times pi r squared. Okay? And that's what I meant to do earlier. Okay, so that's how you find both arc length and area of a sector in degrees. Okay? So, let's go ahead and jump into 13. It says, Pittsburgh, Pennsylvania has a latitude of 40.5 degrees, and Miami, Florida has a latitude of 25.5 degrees. Find the distance between these two cities. Okay, guys, this problem seems a whole lot harder than it is, okay? Think about the Earth as a circle right now. Think about the radius being 3,960, okay? Think about the idea that maybe right here is the location of Pittsburgh, okay? And then maybe the location right here is Miami. Okay, so I know they give us the information about Pittsburgh is at 40.5 degrees and Florida is at 25.5 degrees north, okay? Here's the thing. We want to know the angle between the two. So if this guy is at 40.5, sorry, this guy's at 40.5, and this guy is at 25.5, then what is the measurement between the two? Well, that would be 15 degrees, because 40.5 minus 25.5, okay, tells me that the angle measurement between the two is 15 degrees, okay? So they also give us the radius is 3960, and they want to know the distance between these two cities. Well, that's just an arc length. So I can just say S is equal to 15 degrees over 360 times 2 times pi times 3,960. And you can round it to the nearest tenth. Okay? All right, I'm going to actually let you guys do that in your calculators, and you can figure that rest of the answer out. It's just one step, plug it in the calculator. Okay? Let's move on. I'll kind of get you started on number 14. An irrigation system uses a straight sprinkler 300 feet long that pivots around a central point. Due to the obstacle, the pipe is allowed to pivot only through 280 degrees only. Find the area irrigated by this system. Okay, so you have a straight sprinkler that pivots around a central... Sorry. Uses a straight sprinkler pipe 300 feet long that pivots around essentials. So here you have your straight sprinkler that's 300 feet long. Okay. I'm so bad at drawing circles. Okay. So then, and it says I can only get to go 280 degrees, so I basically get to only go around 280 degrees. And it wants to find the area, so the area irrigated by the system. And it gave us the angle in degrees, so I can say A is equal to theta over 360 times pi r squared. Okay, so I kind of got you guys started there. Alright, so I'm going to go ahead and leave you alone on the rest of this problem. Do the best you can. Okay, and let's go look at 15, and due to my just kind of hiccups, I'll go ahead and try to get you started on 15 as well. Okay, number 15 is a problem that looks so hard, but it's not, okay? Find the distance along an arc on the surface of the Earth that subtends a central angle of 1 minute. 1 minute is equal to 1/60th of a degree. This distance is called a nautical mile. The radius of the Earth is 3,960 miles. Okay, so it says find the distance along an arc, and then it gives us our angle in degrees. I know it technically gives us our angle in minutes, okay, but don't worry about that. Just use the degree. So if we're going to do degrees and arcs, we need to say S is equal to theta over 360 times 2 pi r. And then, guys, you know r. It's right here. It's 3960. And you know theta, it's just 1 over 60. So 1 over 60 times 360, divided by 360, sorry, times 2 times pi times 3960. So now, just simply calculate the rest of this in your calculator, and you'll have it. All right? It's easy. All right, guys. This will be due tomorrow. So, make sure you finish it. Thanks, guys. Let me know any questions you have over email, over Remind, just any way you can contact me. Okay? Thanks.